Now, when the slab, there is a we partially fill a dielectric slab in between both the capacitors plate. So C is equal to epsilon naught A divided by D minus T plus T by K. And if suppose instead of the dielectric slab, this is completely filled with a conductor. So we already know that electric field inside the conductor is 0. So formula becomes quite simple, epsilon naught A by D minus T. Let us quickly complete this, because lots of syllabus is pending. We have to at least complete this lesson so that current electricity will not take so much time. Magnetism, we have to start quickly. Yes, so we have to find out now energy stored in capacitor. So let's say Q is the total charge that is stored in the capacitor, V is the potential between the plates. Work done is actually the potential energy. So entire potential energy gets stored in the form of work done by the cell. Fine. Now coming to this work done. See, work done is charge into potential, right? Work done is charge multiplied by potential. Now, if we are taking a very small amount of charge, we are getting a very small amount of work done. So we don't need this. We want the entire, right? See here. What is dq? Dq is charge per unit, the capacitance that is present. So I can write dq as, it's like using unitary method. For entire Q, capacitance is C. So for unit, it will be Q by C. So for dq, we are finding out that becomes QC by D. All right. Now, how will we integrate this? How will we solve this further? Best method to integrate this is that find the value, put the value of potential, put the value of potential. dW, that is the integration of work done. This will be, what is the value of potential? Potential is Q by C. Q is equal to CV. So V will be Q by C. dQ, integration from 0 to the total amount of charge, that is capital. This is just the important step which you have to remember now, nothing else. This is just physics. All your physics is being applied over here. You just have to now rush up with the calculations. Q dQ over C. C is the constant. Capacitance is the constant. So work done will be equal to 1 by C is the constant. This becomes Q square by 2, integral from 0 to 2. How Q square by 2? Those who are not very well versed with integration, if it is Q to the power 1, yes. So we integrated, x to the power n becomes n plus 1. See, x to the power n is there, like Q to the power 1. So add 1 here. 1 was here, add 1. Now whatever is the numerator power that you are getting, divided. So 1 plus 1 will get divided by it. So that's why I've written it as Q square by 2. Integrating from 0 to capital Q. Clear? X to the power n is integrated using this formula. All those who have forgotten their integration, this is how we integrated. X to the power n plus 1 divided by n plus 1, which has been obtained. All right. So now when we substitute in the values, this becomes work done. This will be 1 by 2C. Capital Q square minus 0 square. Yes, upper limit first, then the lower limit. This is the upper limit. This is the upper limit, which is Q. So what is the formula that we are obtaining? Work done is equal to Q square by 2C. Because 0 in any way is 0, right? 0 square will be 0. So this entire work done gets stored in the form of potential energy. All right. So your potential energy is actually half Q square by C. This is the formula of energy stored within a capacitor. Now class, this is one formula if charge and capacitance are provided. Suppose charge and capacitance, instead of this, let's say only capacitance or potential is provided. Charge is not there. Now how will you use this formula? So what we'll do? See, we know Q is equal to CV. So Q is equal to half, not Q, energy. Energy is equal to half. What is charge? Q square. That becomes C square V square divided by, here we have C. So this will be cancelled. So one formula of energy, this will be half CV square. This is also a very good formula that is used. So if charge and capacitance are given, we'll use this. If capacitance and potential are given, then we'll use this. Whatever third case, charge and potential are given and no other quantity is mentioned. So if charge and potential are given, C is equal to Q by V, right? We'll substitute this. So U is equal to half. This becomes Q squared. And instead of C, we can write Q by V, right? So QQ will be cancelled. So one more formula of potential energy we have obtained is half QP. So this is the third formula. So all the three formulas are present. You can derive any of them, and whichever two quantities are given, next one can be calculated like this. Question also, let's see. Do one thing. First, note down this derivation, then we'll discuss the question. Note it. Yes, class. So this question says that a parallel plate capacitor with area 10 centimeters square and separation 5 millimeters have dielectric plate of thickness, dielectric constant. You have to find out capacitance, charge, and energy. See, firstly, write down everything that is given to you. And you have to first identify which case is given to you. See, 4 formula we had discussed. C is equal to epsilon naught A by D. One we discussed what C is equal to K epsilon naught A by D. Third one, C is equal to epsilon naught A by D minus T plus T by K. And C is equal to epsilon naught A by D minus T. Now read the question and all of you in the chat column answer me. Which of the following will you use? 1, 2, 3, 4. All of you quickly write in the chat column. According to the question, what do you think? Which formula should be used? Aliza, Hussein, Amna, Deborah, Fadil, Fia, Mariam, Rajita, Sidra. Okay, Fia has answered. Amna has also answered. Okay, correct. Amna's answer is right. Okay, Mariam has also answered. Okay, Fia has changed her answer. Rajita. Okay. Deborah, what about you? See, all those who, I think till now only one student has answered correctly. Only Amna's answer is right. See, when it is saying a parallel plate, identification of it is important. Identification of the question is, the formula is important because all the formulas you have studied and this is a completely formula based question, right? So you have to fit in the formulas well in this. A parallel plate capacitor, area is given. You will see thickness of slab is given to you and separation between the plates is given. If these are the plates, the separation between the plates is 5 millimeters. And it is saying that slab is 3 millimeters in length. So will it coincide over it that you people are using this formula? It won't coincide over for usage of the second question of why most of the students are answering this because dielectric slab is being present for, and for dielectric we use this formula. No, we use that formula when it is completely filled with dielectric. Yes. When it is saying the thickness is 3 millimeters, means this part is 3 mm. So means some portion is being left. D minus T is also there. And students who are answering fourth part, for the calculation of fourth part, there has to be a conductor. There isn't any conductor in this question. So this will directly be eliminated. Air is also not present. This will also be eliminated. There can be a confusion between 2 and 3. 4th and 1 are not there in your list. They shouldn't be in your list. Be clear with it. This is for air. This is for dielectric slab. Now for the second part, no. When it is saying K epsilon naught A by D, for the second part, if the slab's length or if the separation between the plate was same, or there wasn't any slab given, just dielectric constant was given, then you would have used second. Right now it is saying 3 millimeter and 5 millimeter means some spaces are left, right? If some spaces are left, then wait. So it should be the third formula. Now see, you just have to substitute in here. Epsilon naught A by D minus T by T plus K. Now what all things are mentioned? Area is 10 centimeter square. So we'll be using all the quantities in their SI form, standard SI unit. This is 10 into 10 to the power minus 4 meter square. Separation between the plates is 5 millimeters. 5 into 10 to the power minus 3 meters. And thickness is 3 millimeters, which is 3 into 10 to the power minus 3 meters. Epsilon naught permittivity, 8.85 into 10 to the power minus 1. Now see, permittivity's value, please remember class, because this won't be mentioned anywhere. right? Area discussed. So this is how you have to find out the value of capacitance. Just put in everything over here. C is equal to 8.85 into 10 to the power minus 12 into 10 into 10 to the power minus 4. Epsilon naught A by D. 5 into 10 to the power minus 3. D plus T, that is 3 into 10 to the power minus 3, minus T by K. Dielectric is given how much? 2. This you have to solve, and what I do not remember the answer of this. Just check whatever answer is coming, and I'm just telling you the method in the second part. Now voltage is already given to you. Charge and energy stored if potential is 100. So if V is 100 volt, V is given as 100 volt, so you will use Q is equal to CV. C from the first part, V from here. This will give you. And once you have all the values, now you have C, now you have V, now you have Q. Any energies formula which you are comfortable with, half CV square, half, any formula which you are comfortable, because right now you know all the three quantities that you can use and find it out. Half CV square and any other formula. All right. Somebody who will write this part first, please let me know the answer, because I do not remember the answer. People just write it down. And I hope this confusion is clear. The main part, no more than the calculation part of this question, is writing down all the understanding which formula to be used. Once that is clear, formula based question you all will be able to answer. And these questions are formula based. You just have to remember their derivation. Derivation अच्छे से याद कर लो. Derivation will be given and asked in the exam. Secondly, usage of which formula you have to use. Write it down, then we'll see sharing of potential. Yes, I'll show the question bit. All those who have not written the question, write it down. So next is last is just series and combination of capacitors. No? So we'll complete the lesson by tomorrow. Tomorrow we'll end this lesson because this shouldn't be dragged much. Now we have to brush up with current electricity will not take much time. Current electricity is a short lesson. It will not take so much of time because we'll be studying resistors. Whatever we have, we'll be devoting time in resistors. We'll be using that same in capacitors. So it shouldn't be. Magnetics I want to start quickly because rest of the lessons then it will go further. One more thing, class. Spherical capacitors, I told you this is all about parallel plate capacitors. Spherical capacitors, no, I told you that this is not very important for you, but still, to be on the safer side, we'll just discuss the derivation. A small derivation is there, and it's not difficult. We'll discuss it. Cylindrical capacitors, we are not going to discuss. Now, see, if two spheres are given, these are the two spheres. One is having radius R1, one is having charge plus Q, other one is having minus Q, R2 is the radius. Yes, I'll show it, Fia. Just wait. I'll scroll it up. Let me discuss this and I'll scroll it from. Okay. So yes, when I'm talking about potential here, potential due to, see, both the spheres are present, right? So when I'm talking about their potentials, net potential, that is going to be K Q by R1 minus KQ by R2. Why KQ? Why minus KQ? Because the second charge is negative. This is a negative charge, right? So KQ by R1, this is minus KQ by R2. So one thing we can take common is KQ. So this is left 1 by R1 by 1 by R2. Okay, so C is equal to Q by V. Yes. So charge divided by potential. What is the value of potential? The entire potential I'll put in my answer, K, Q, and this will become 1 by R1 minus 1 by R2. Firstly, QQ will be cancelled. Secondly, K, I'll write down the value of K as 4 pi epsilon naught. It's 1 over 4 pi epsilon naught. So 4 pi epsilon naught will go above. And let me take the LCM, that becomes R2 minus R1 divided by R1, R2. So this will also go up. So final value is 4 pi epsilon naught R1 into R2 divided by R2 minus R1. There are some small topics which I want to discuss with all of you. One is this. Those I'll discuss now. So this is the formula. Just remember the formula. If something has to come in your exam, this will come directly from the formula. Formula based question will be there. And maximum it can happen that the derivation is 17.7 into 10 to the power minus 3 is coming your answer. Okay, Fia. Someone else also look. Do you want to write from here? Fia, do you want to copy this part? 10 to the power minus 13. Okay, someone else also please let me know. Okay, from here I have kept it. Slowly I'll scroll it down. You can write it, and 1 or 2 derivations I want to do in the form of questions that I'll discuss. Sharing of capacitors also I want to complete. I'll let you know, Fia. Yes, someone else also. I do not remember the answer actually, Fia. I'll just let you know. Your answer I have announced. Someone else, if someone else also gets it, I'll let you know it. See, this question says that calculate force between the plates of capacitor. See, this can come as a derivation also to you. It can come as a separate question. We are doing this derivation in the form of question. It can come definitely as a derivation also. Please mark this and the next question also as important. This is not a question that we are, or a numerical we are solving that the values will be different or something else. This is like a derivation. It can be asked as a derivation. Derive the force between the plates of capacitor. The electric field we had studied is sigma by 2 epsilon naught for a single infinitely long sheet. Remember the Gauss theorem's application when we did. And sigma is equal to charge per unit area. See class, when you are performing the derivation, no, understand in your board exam, certain criteria is marked, which you have to follow. And that is also present in the marking scheme. Like when you're starting and deriving this, write it down. Let there be two parallel plates having area of their cross section as A with surface charge density as sigma, under the influence of electric field E having charges plus Q and minus Q. Like this, mention this that one thing story once. All right. If you will not mention the variables, then how will the examiner assume that you are writing the surface charge density? You could have written the linear charge density also, right? So try to mention these things will be scoring, and these will be helpful to you, because the marking scheme has half marks divided for every step. And if you are not defining the terms which you are using in your derivations, then you will be at your loss. Okay, so try to mention it initially or already before starting it. I am not writing, I only write it and mark it as an arrow at the end. But when you are writing for your exams, try to write down that story thing first. This is this, this is that. So yes, let's replace this. This becomes Q by 2 epsilon naught A. Now, what is force? Force on the second plate we are calculating, because the electric field is by the first plate. So that becomes minus QE. F is equal to QE. Remember this formula, we have done this. So force becomes minus Q into Q by 2 epsilon naught A. So what is the final formula of it, which we are deriving? Minus Q square divided by 2A epsilon. Write it down. One more this type of question I want to discuss with you, which you have to remember. And remember this formula also, the forces formula, because every time you cannot sit and derive. This can come as a numerical also. Fine. Yes, class. The next is calculation of energy density. So calculate the energy density between the plates of capacitor. So energy density basically means energy per unit volume. Likewise, you will be studying in current electricity, current density. So densities means something per unit area or per unit volume. Here we'll be talking about energy per unit volume. Now, what is energy? Energy is half Q square by C, right? What is volume? If the area is A and thickness is D, so volume we write no, area multiplied by thickness, that becomes AD. So what is the energy density equal to? Energy density is equal to energy, that is Q square by 2C, and volume is AD. Q square by 2C, 8. Fine. Now, see, capacitance also, let's write it as epsilon naught A by D. If we write the value of capacitance, this will become Q square by 2 AD. Instead of capacitance, we'll write epsilon naught A by D. So DD will be cancelled. We are left with Q square by 2 epsilon naught A square. Yes. Now class, sigma is charge per unit area. What is sigma square? Q square by A square. Can you see here? Can you identify? Q square by A square, then it should be sigma square. So this becomes, now see, this becomes sigma square, this entire term. So this becomes sigma square by 2 epsilon naught, right? Half sigma square by epsilon naught. Now class, electric field between both the plates was E by epsilon naught, right? So if one thing that we can do is, see, if we multiply this by epsilon naught and divide this by epsilon naught, we'll get this as sigma square epsilon naught by 2 epsilon naught whole square. From here, if you look here, sigma square by epsilon naught, what this should be? If E is sigma by epsilon naught, E square will be sigma square by epsilon naught square, yes? So this is our final answer. Electric field between the plates is sigma by epsilon naught. So final answer is half sigma square by epsilon naught square becomes E square, and we are left with 1 epsilon naught. And what you have to remember, energy density is directly proportional to electric field. This is asked a lot. This question is often asked in your exams. Fine. So this shows that energy between the plates of capacitor depends upon electric field. Sharing of capacitors is also not a very lengthy topic, but it's not a very small topic also. Let us complete that. Note down this. And this again, remember this formula, and this can also come as a separate derivation. Both the things. Now class, sharing of capacitors. So sharing of conductors we are discussing in general because you can get questions on conductors also. So conductors or capacitors, both are, we are taking it as the same because derivation is also same, concept is also same. See, it's like you are having one capacitor, it's having its energy, it's having its own value of potential, capacitance, everything. You have one more capacitor, it is also having its own values of potential, capacitance, and everything. Now, when you have connected both of them in series or in parallel, you have connected both of the capacitors. So there is sharing occurring. What happens is that from the capacitor that is having lesser value of charge, let's say one capacitor is having 5 coulombs, one is having 2 coulombs, right? So if this loses one is having 5, another one is having 2, right? Or let's say this is having 3. So suppose if this loses this one, 5 are there, 3 are here. If this loses this charge and gives it to it, are both of them equal now? So this is like charges move from the capacitor or conductor having having higher potential to the one having lesser potential. All right, from the higher one to the one having lesser potential until their potentials become same. All right. Now see, this is what is meant by sharing of capacitors. Both of them are connected. Initially V1 was greater. Now finally they are having the same potential. So this potential, no, which has been obtained after their sharing, that is called as common potential, whose formula also you have to remember. Small derivation is there, that also you have to remember. Now see, this is the case before sharing. This is the case before sharing. Capacitor is there. C1 is the capacitance. V1 is the potential. C2 is the capacitor. V2 is the potential. So charge is C1 V1. Energy is half C1 V1 square. Charge 2 is C2 V2. Energy is half C2 V2 square. This is before sharing, right? Before they are connected. Charge will be what? If C1 is the capacitance, V1 is the potential, there charge is going to be C1 into V1, right? And energy is also going to be in this manner, only half C1 V1 square. So like this, these are individual and independent. Now, once they have connected after sharing, see this, they have been connected. So capacitance will be C1, capacitance 2 will be C2. But both of them now will not be having potential V1 or V2 or V3 or V4. They'll having one same potential because the concept of sharing was this only, that the charges will move until they become equal, right? So there is a common potential which is equal in both of them. So now what the charge will become? C1V. What the energy will now become? Half C1V square, not V1, V2 anywhere. Q2 prime, the new charge after sharing, after they have been connected, is C2V. Finally, it is half C2V square. Now, this is what is meant by sharing of capacitors. Now see, on connecting two capacitors, charge flows from one at higher potential to lower potential until they acquire the same potential. It means charges, suppose this was the case. Now I was telling you, this is the case. Now see, if one has been lost, this is gaining one. Total amount of charges, just look, 5, 3, 8. Initially it is 8. This has been lost here, this has been gained. Still 8. It means charges that have been moving. Charges are just transferring. Total amount of charge in your system is still remaining the same. So we can say charge before sharing is equal to charge after sharing. That is Q1 plus Q2, which were before sharing, and Q1 prime plus Q2 prime. Yes, Q1 dash plus Q2 dash, the new ones, they are same. So I've just put their value, C1V1 plus C2V2 is equal to C1V plus C2V, which we have written initially. And from here, if you look, we can take V common. So what is the formula of common potential? C1V1 plus C2V2 divided by C1 plus C2. This is the formula of common potential. This is the formula of common potential, which you have to remember, learn. Loss of energy we'll do. First write it down, then loss of energy we'll see. But remember this one concept, last time I'm repeating. Two conductors are there, two capacitors are there. Charges will flow from higher one to lower one until their potential becomes same. Once same potential is achieved, then the charging stops. Write it down. Any doubts you have, text me. I'm here. Now see, when we are talking about loss in energy, then we have to find out initial minus final we are doing. See, why are we doing initial minus final here? We are not doing final minus initial minus final. Why? Because see, initially it was having a higher voltage, right? So this value is greater. That's why we are using it. And secondly, we want to find out the loss. If you are using higher minus greater, that is final minus initial, you will not get the loss, you will get the change. For loss, you have to get the negative side, right? That's why we are directly using ui minus uf. So initially, this was half C1 V1 square. This was half C2 V2 square, right? This is initial energy minus final energy half C1 V square plus half C2 V square, because common potential has arrived, right? Now let's take common potential common here. Delta U will become half C1 V1 square plus half C2 V2 square. This will become half V square. This is C1 plus C2. Fine. Value of common potential, we have calculated C1 V1 plus C2 V2 divided by C1 plus C2. Right? Put in the value over here, square it and put it. See, if you square this up and put this up, this will be delta U will be half C1 V1 square plus half C2 V2 square. This was already there, half C1 plus C2. This was also there. Now what we have brought, C1 V1 plus C2 V2 divided by C1 plus C2, their whole square, right? Let me write numerator and denominator separately, their squares separately. This is numerator square, this is denominator square. Remember, half C1 plus C2 V square. V I have squared it. This is the same. Why have I written it separately? Because C1 plus C2, this can be cancelled. All right, C1 plus C2, this can be cancelled. That's why I've written it separately. Fine. Now, one C1 plus C2 will be left in the denominator. No, let's do one thing. Let's take this as the LCM. What is left in the denominator? 2 and C1 plus C2. Let's take the proper LCM. LCM will be 2 C1 plus C2, right? 2 here, 2 here, 2 here, and C1 plus C2 here. Right, so it's 2 C1 plus C2, that's going to be the LCM. So C1 V1 square. So we have to multiply C1 plus C2 here, right? That becomes C1 V1 square into C1 plus C2. Plus here also we have to multiply C1 plus C2, C1 V2 square into C1 plus C2. Getting it? This is normal LCM we take. If 2 is here, this denominator is missing, so we multiply it in the numerator. Same way we are doing it. And what is left? Acha, minus sign is here, no? So we have to convert the sign. It's like A plus B whole square, but with a negative sign. So that will become minus C1 V1 square minus C2 V2 square. Not only C2 V2 square, C1 square also, no? C1 V1 whole square is there. So this is A square plus B square, but we are having a negative sign, so this becomes minus. And this is also minus 2 C1 C2, right? So let's do one thing. Let's open up the brackets. Let's multiply C1 with this first, C2 with this, C1 with this. Let's just open up the brackets. This is a little lengthy, I understand. But once you will solve it by yourself, this actually isn't lengthy. It's just because the denominator is so huge, C1 plus C2, that's why it becomes. So see, this becomes C1 square, V1 square, plus, then we'll multiply this, that becomes C1, C2, V1 square. Again here, C1 square, V2 square. This is C1, C2, C1 into C2. Okay, C1 into, yes, C1 whole square, V1 square, yes. This is it. And then this becomes plus C1, C2, V2 square. Minus C1 square, V1 square, minus C2 square, V2 square, minus 2 C1, C2. This was already left. Please class, practice this derivation, I will suggest you. This is actually not difficult. Okay, so what all things are getting cancelled? C1 square, V1 square, yes, this is getting cancelled. C2 square. Okay, here C2 was there, right? C2 square. So this, they will also get cancelled. Anything else? Nine, huh? So C delta U, change in energy. This will be C1, C2, V1 square. This is left. And what is left? Minus 2. Let's do one thing. Let's take C1, C2 common. It's coming everywhere. So this becomes V1 square. This becomes V2 square. This becomes minus 2. Oh, here V1, V2 is also there. No. V1, V2 will also be there. Here also V1, V2 will also be there. So 2, V1, V2. And what is the denominator? 2, C1 plus C2. Now see, A square plus B square minus 2AB. This is similar to one identity. Remember, this is similar to one identity. A minus B whole square. This is similar to A minus B whole square. Yes. So this will become C. C1, C2. This is A minus B whole square. So V1 minus V2 whole square divided by 2, C1 plus C2. This is the loss in energy. Fine. This is the loss in energy. So class, this looks very lengthy, but it's just simple mathematics. All right, simple multiplication and all. Multiplication usage of identity. Please try it once by yourself also. Note it down right now. Any doubts you have, please get it clarified there and there only. Last step means this one, Fia. This one you're asking. See, in this, what we have done, see, how do you take the LCM? If something is given, something is by 2, something was by 2, something was by 2. So how do we take the LCM? We multiply them. So 2 into C1 plus C2. This was the LCM obtained. So we have just multiplied C1 plus C2 wherever it wasn't written. Then we have opened up the brackets, cancelled the terms, and used the identity. That's why I'm seeing all of you to practice it once by your hand. Once you will do, no, once you will go through, then only it will be clear. Okay, few people have completed. You can leave. Tomorrow we'll continue. Let's end this lesson. Series and parallel combination, just a bit I have to discuss. Okay, thank you so much.